Hi, and welcome to class 2 of RenderMan for Houdini Solaris. In this class, we're going to be taking a look at setting up our geometry using the RenderMan attributes. So let's dive into Houdini and we'll take a look at how to set that up. One of the most powerful features of RenderMan is its ability to create highly detailed, beautifully intricate geometry at render time. This can be advantageous in a number of different ways, from creating the scales on a dragon to creating beautiful detailed fabrics and cloth materials on characters, and also creating rocks and different patterns on environmental geometry in the background. All of this can be done at no expense to the scene complexity of the scene that you have loaded into the viewport of the software that you're using. So let's jump in and we'll see how this system works, and we'll have a look at all of the different geometry attributes which you can add into RenderMan for Solaris. So to get started, we're going to load up our class 2 scene. And what you'll be able to see here is we've got this RIS interactive render going here. And right in the middle of the scene here, we have an example of a very, very simple piece of geometry, which is actually a cube. So you don't get any more simple than that. Maybe a triangle would be simpler than a cube. And the reason why I've used a cube for this example, even though the displacement UVs don't completely wrap around it like a sphere for these scales that are on it, the point of using a cube is just to show you that basically, even if you have a geometry which is very, very light in terms of its weight, you can add incredibly complex geometric surfaces on it using RenderMan settings. These include things like subdivision and things like displacement. The other things that you can add using the rendered geometry settings is things like holdouts and mats, so that you can basically have objects receive shadows or cast shadows but not be visible. You can have it visible to secondary bouncers but not primary bouncers, and all different attributes in there. So let's take a look at how we can create geometry first of all, and add it into our USD stage. And then we'll take a look at how we can add this render geometry settings node in here, which is super helpful. So if we just disconnect this whole chain here, which has been created already, and we'll just go through how to build up this network in here. So what we can do first is we're going to do a SOP create in here. And this is where you can create geometry inside the USD scene and merge it into the scene. So inside here, you can create any kind of geometry that you want to make inside Houdini. And then basically you can pull that into your USD scene. So for example, what we're going to do is we're going to create a cube in here, and then we're going to just put some UV coordinates on it. And now we can see we've got a cube in our scene with some UV coordinates on it. Now, when we put our scales displacement on it, it's not going to wrap like a perfect sphere onto this when we subdivide it. But basically what RenderMan is going to do is it will subdivide this geometry. So what we can do is we can take a preview of what RenderMan's actually doing inside the viewport here and take a look at what it's doing under the hood with our geometry. So if you've watched Toy Story before, you'll know that the beautiful curved shapes on Buzz Lightyear are perfectly rounded and smooth. You don't get like faceted polygons on there. You get these beautiful smooth curved surfaces, and the way that's done is by a subdivision. Even a super advanced software like Unreal Engine 5, it doesn't feature render time subdivision, which was something that RenderMan was able to pioneer in the early 90s and 80s when it was first designing the Rays renderer. And what subdivision at render time basically is it's able to subdivide the geometry if the geometry is beautifully modeled sub-D ready geometry, not polygon model geometry. It's able to subdivide the geometry at render time. And what it actually does is it will subdivide it to basically 1 pixel per face. So what you'll see is something like where you'll have basically the subdivisions of each triangle will be the size of a pixel on screen. So you could even end up with something that's very, very, very densely tessellated in the model, whereas you can zoom in as much as you can and you basically are seeing just a perfectly smooth object where you can't even make out the individual faces on the edge. So what that basically means is when you zoom out to the edge of the object, you're getting this perfectly curved surface on the object of hard surface models. And this is why companies like Weta and Industrial Light and Magic still use hard surface models created in Maya to do all of their hero assets for robots, spaceships, X-Wings, and all the avatar robots and things like that, is because they can use this subdivision system to add these beautiful curved, infinitely detailed edges onto objects, rather than having polygon models where you have to sort of like manually add detail into the polygon model. So those subdivisions are very expensive and difficult to model. The payoff is actually at render time when you're able to let the software subdivide it with very little cost to memory overhead at render time. And then you're able to have a super, super lightweight model in the viewport or in the USD file that you can use to basically position and place the object in the scene. So with something really simple, that's a low poly object like this, what you'll actually get at render time is something like this. So you're able to position it in the scene and lay it out with a really lightweight object and then render it at full detail. So we'll just delete that out of there. And let's take a look at how we can basically set this up in our scene. So I'm just going to delete this one here and go over to here. So I've got my box set up in the scene, and I've just translated it in the scene. So you can see here with this sub create, you can translate the object inside the sub create if you want, and move it around by transforming it, or you can transform it on the actual node itself. So if you position it around the scene, you can rotate it, you can scale it if you want, and basically you can set it up and position it where you want in the scene using either the geometry inside or the geometry on the top. So very, very helpful and easy to use to put planes and different assets into the scene and add them into your USD graph. Now, the next node that we're going to be using is the render geometry settings nodes. You can bring that up by typing in render geometry settings, and it'll come up here. And when it comes in, what you'll see is that it enables you to get render geometry settings for both Karma and RenderMan. Now, because this is Houdini Solaris, we've got Karma by default, which is the native Solaris Houdini renderer to supersede Mantra and work within the Solaris context. And then RenderMan over here has got all our RenderMan geometry attributes on there. So you can create new RenderMan render geometry settings using the tab menu. Now, once you've created that, let's take a look at some of the settings that are in there, and we'll adjust them. So I'm just going to plug this back into my, I'm going to merge this into my USD scene, and I'm just going to go down to the bottom and get all my lights and my scene working. So what we'll do next is we'll just fire off a RenderMan RIS interactive render. And we'll take a look at the different components in this render geometry settings window. So what we're going to do is we're just going to click on this one so we can see it. And you just want to make sure that you're on the RenderMan tab, not on the Karma tab. So let's take a look first of all across the panels in here. And we've got here instance attributes and prototype attributes. So let's take a look at some of these as we go across. So first of all, on the shading, I've actually enabled these checkboxes in here, but as they come in by default, you can use this drop down which says set or create. There's also the ability to say set if exists, add if exists, block, or do nothing. And that will be on the different controls. So by default, the controls will actually look like this, which will have a circle on it. And then if you press set or create, it'll create this little pen thing here. So basically, you can swap between having it blanked out or having it set to set or create. So inside here in the first panel, we've got here RI matte. So basically, if you select this, what it'll do is it will matte out the geometry of your object in the scene. This can be really useful for objects that you want to give to compositing, where you want to matte out a specific object, which could be, for example, a car in a car TV commercial, the ground, or anything like that, which you have in the scene. So that's really useful to be able to set on a per object level mattes that are coming in there. The next thing that you can set up is you can set up LP lighting groups in here. And basically in later lessons when we're going to go through the lighting, what that allows you to do is connect basically lights to specific objects. So you could, for example, have a directional light which hits this object and it can basically be included with this, this piece of the geometry, and then it can exclude other lighting LP groups. You can also use that in render passes as well. So it's a really helpful system to use. Now, as well as having the RI matte, you also have a holdout here. So when you enable a holdout for the object, you're basically able to get the bounce lighting of the object from the environment, but it'll also have it as a matted out object. So rather than having it completely black and cutting out the whole scene, what it'll basically do is it will cast shadows onto the environment, and it will also receive bounce lighting, but it will be transparent. And that's helpful for things like if you had, say, for example, a transformer which is standing on invisible ground, and you want it to cast shadows on the ground, and you also want the lighting to be interacting with the invisible surroundings. So you'd be able to cast shadows and receive lighting from invisible objects. It's super helpful for setting up things that are in live action plates. Now, also in here, we've got the max diffuse depth and the max specular depth. So what you can do is you can actually set the parameters in here for the different render settings. We won't be using that for this particular class, but it's good that you can have the controls in there to set those up. Now, one thing that's helpful in here is you've got the visibility. So one thing you've got in here is the camera visibility and the indirect visibility. So having the ability to switch off the camera visibility can be helpful in certain situations where you're trying to basically shadow parts of the scene with objects, but you don't necessarily want them to be visible to the camera. So you can see here the top of this clapperboard here is actually being shadowed by this object. So if I select it in here and I translate it down, you'll be able to see that I'm able to shadow these objects, but still keep the visibility to to switched off in this render geometry settings. So it is really helpful to have the controls over these objects so that you're able to basically manipulate the scene, but without having to have everything switched on all at the same time. So that's really, really super helpful. Now inside prototype attributes in here, we're not going to use advanced or user, but this is where you can add mat IDs to the object so that you can basically have this cut off in compositing software. Most of the time you can use CryptoMat to do that, but the mat IDs is really helpful if you have a specific set of mat IDs for, let's say, a vehicle or a character, and you want to have specific parts of it able to be pulled out for comp teams. So in the prototype attributes in here, we've got our enable displacement button in here. So by default, this is set to do nothing, and it'll be either checked on or checked off. But by default, this probably will be off. Also, the radius will be set to 0 by default. So basically what you'll have is you'll have the object set like this. The second thing that you'll have possibly is inside the SOP create, you'll have the geometry handling set to not treat geometry as subdivision surfaces. So by default, when you create a box inside the SOP create, it won't automatically assume that you want to create subdivision geometry out of your surface. So in the SOP create itself, that's where you can go and select the treat polygons as subdivision surfaces. And then instead of rendering it as flat polygons, it will actually subdivide it based on the render settings that's in the render geometry settings. So you can see here it goes from a box into a perfect sphere in the scene. So for the geometry render settings in here, you've got this enable displacement button in here. And when you select that, you're able to then have the option to add displacement shaders onto the object. So also the radius here is important. This is basically the displacement bounds of the object. So if we set this to 0, which is what it's set to by default, there will be no displacement bounds on the object, even though it has a displacement surface on it. So the displacement bounds is basically where the edge of the displacement vanishes on the object. So depending on how much radius you have on the displacement bounds, is going to gauge how much it's able to displace the geometry off the surface of the object. Now, when you set the displacement bounds unnecessarily hugely large, one of the issues is it can use up a bit more memory for rendering. So it's good to have the displacement radius set to the limits of your displacement of your object, whether it be mountains or rocks or dinosaur scales or whatever it is. You want to make sure that this is matching the scale of your scene for displacement. Now, the next thing that you have in here, which is really good, is the dicing and micro polygon length. Now, micro polygons are the subdivisions that we looked at and we did manually on the sphere, where we put it to 12 subdivisions and it basically diced the sphere into being very, very, very finely tessellated. So the micropolygon length is basically the length of the micropolygons which create the rendered shape. And why that's really useful is if, for example, you have a very sharp, detailed geometry that you want to put onto the displacement, if you find that the micro polygon length is too big, what you'll actually end up with is a kind of blurry, fuzzy edged details on the displacement. So even though the displacement texture might be 4K or some super high resolution of UDIMs of displacement, what you'll actually see in the render is this kind of smooshy, lacking detail final render on your creature or on your environment object. So the micro polygon length, which is set to 1 by default, it will basically help you sharpen up the detail of things that are using displacement on your renders. Now, things that are where you would use a really, really high micro polygon length would be something like if you have a glass or metal object which has text which has been etched into the object, and it has very, very sharp corners. So if you think of like some kind of Beretta or something, and it's got like the Beretta writing etched into the metal, that would be where you would use a really smaller micro polygon length to get those sharp corners on there. So you can see here at the micro polygon length of 1, we're still getting kind of soft edges on there. So if we try to put this to 0.5, what you'll see is where it's got these kind of like marshmallowy soft corners on there, as you increase or decrease the micro polygon length, you'll get sharper and sharper details in the geometry itself at render time and at the expense of the memory and the resources it's using to render. So you can see here, instead of having those kind of like soft clay looking edges on there, now we have these really, really spiky, sharp edges on our geometry. So the micro polygon length basically gives you sharper and sharper details of the displaced surfaces that you're creating. Now, if you just put the micro polygon length to like 0.001 or something like that, you'll eventually run into render optimization problems. It may not crash the computer, but it's just not an efficient way to render all objects by just smashing the micro polygon length to like the minimum possible amount. A good idea is just to visually zoom into the scene, verify what you're trying to achieve with your displacement, and then just set it accordingly to retain the detail that you need. Now, the other cool thing about micro polygon length is it gives you a look at the subdivision and how it actually works on the shape. You can see here, if we set the subdivision to 5, we're getting this really smooshy, kind of like not very tessellated object. And that basically can give you a look under the hood of what RenderMan is actually doing behind the scenes to actually tessellate and subdivide the geometry. So while you wouldn't use a micro polygon length of 5 for production assets, it just gives you a look at how it's actually adding geometry in there into the scene to create the displacement and the geometry that's building in there. So we'll put that back to 0.5, and now we're going to have a look at our motion blur settings in here. So to change our motion blur settings for this object, what you can do is you can go over to enable motion blur, and we'll do set and create. And then in here, we've got the enable motion blur checkbox put on. So what that basically means is when you have keyframes on the object, so if we select that object here and we move it in our scene, might just go to the Houdini GL viewport so I can keyframe this easier. So this is our object here. And then at frame 24, if I position this across the scene here, and then I'm just going to add a keyframe into here, into my transform data. So I'm just going to add the keyframe to position it. And then I'm just going to go to the next frame and put some quite fast movement on there. And I'll just keyframe that. And so now we'll have our object zooming through the scene. Now, while this is moving on this frame, if we go back to the rendered view and we basically take a look at the at the RenderMan view with motion blur, what we should be able to see is that we're getting basically some motion blur on our moving object here. Now, if you want to change the motion blur and basically switch it off, what you can actually do is you can switch off enable motion blur, and it will basically delete the motion blur on the object. So this gives you basically object specific motion blur controls over the different objects in your scene. Now, where this can be really helpful is, for example, if you have a film like Spider-Man Into the Spider-Verse, where you have some objects in the background which are moving, and you've got other characters or things that you want to have no motion blur on because they're a specific style, it can be really helpful to be able to enable or disable the motion blur on a per object basis, especially for films nowadays where there's much more stylistic looks and artistic direction inside animated feature films and different movies with VFX in them. So the ability to switch that on and off is really, really helpful. Now inside here, we've also got velocity blur and no velocity blur on our settings here. And we've also got acceleration blur. So that gives you the different options for being able to set that as well. So if we go down to here and we set this to velocity blur, you'll be able to see that basically changes the controls for the object. Now, the other helpful settings in here is you've got the geometry time samples, where you're able to sample it as it's moving through space based on the different subframes. And then you've got the transform time samples. So basically where this is really useful is if you've got, for example, a shot in the movie Cars or in a car TV commercial where you've got a RenderMan wheel spinning really fast, what you can do is you can basically, let's say the wheel is spinning at 100 kilometers an hour, and it's spinning really, really fast, and the render comes out and the time samples of the blur looks a little bit weird because what it's trying to do is basically interpolate between two different samples that it's got on each frame, and it's not quite enough samples to get that round shape of the metal rings of light coming around the tire. So what you can actually do for fast moving objects like helicopter blades and wheels is you can actually increase the transform and geometry time samples in here. And what that'll allow you to do is basically get spinning or fast moving objects to get more accurate motion blur on those particular objects. So that's a really cool effect for wheels and different objects like that. And I've definitely used that before with RenderMan, and it's really super helpful. So now that we've had a look at some of the render geometry settings, let's take a look at the displacement now, and we'll see how we can add that onto our scene. So we're just going to disable motion blur in here just for render speed. And now we're going to take a look at our material library and our assigned material. So in later classes, we're going to build all different material networks. But the main thing I want to show you here is how you can actually add displacement onto objects using the materials that are in the scene. So inside the material library here, I've used an aluminium brushed circle from the material library. And so what we can do is we go into new paint tab in here and we go into RenderMan. We've got this amazing preset browser here, which is filled with really cool materials, surfaces, and all different shaders, which you can pull in and basically use to quickly create different effects for tests, for glass, minerals, paint, all kinds of different surfaces. You can also pull in llama surfaces, Pixar surfaces. There's libraries and libraries and libraries of these things on the Pixar website, which you can download and pull in here and use for different projects that are all free off the Pixar website. So you can basically grab all these different materials and then add them into your scene. So for example, if you want to grab something like snow or slushy ice, all you have to do is you can even select an object and you can say import and assign to selected. And what it'll actually do is it will create a material library in here, and it will assign it onto the object that you have. So if we pull this out and we just connect this into our object here, be able to see here that we're able to put that snow material onto our object. So it's very fast, efficient, and fun to use the material library to create different shaders and assign them onto parts of your scene for doing different tests. So it's going to delete that and go back to my other one. And let's take a quick look at how this displacement material is set up. So inside here, I've just created a Pixar material builder, which you can use by pressing Tab, type Pixar material builder. And this will create an empty folder, if you like, where you can create all different types of Pixar materials to assign onto the geometry. You can also create lots of different Pixar material builders and place them into this material library folder here. And then once you've got all the different material libraries in here for an asset or for a scene, you can then assign all of these materials onto the objects similar to Katana. So it's really, really easy to basically get these all working and get them set up. So the cool thing about Pixar Material Builder is the node-based procedural nature, where you can basically build what you want inside. So if you ever looked at this aluminium brush circle, which is inside, came from the preset browser, you can see here that we've got a Pixar surface, we've got the Pixar texture of the brush circles, UV coordinates, we've got some tangent fields in here to adjust the material, and then we've got our output on here. So very, very simple, but basically allows you to use different types of material setups in there. So inside our sphere material that I've got here on this ball, what we've got here is basically something similar, except I've used a llama surface in here with a llama diffuse. So llama was the material system developed by Industrial Light and Magic, and first used on Solo, and it's been used on all of the ILM movies since then. It's a great material system which is sort of node-based, and it allows you to build these node-based networks and plug them all in together. So inside the llama surface, we can see here we've got material front and material back, and then inside here we've got the llama diffuse. So if you want to create different materials, all you have to do is type tab, and then you can type llama, and you've got in here diffuse, conductor, dielectric, emission, sheen, subsurface scattering, translucent, hair, and tricolor subsurface scattering. So there's so many options in here of different materials that you can use for skin, for all kinds of different objects like food and wax. You can use metals, and you can also use specular materials and multi-layered car paint type materials. So all the different types of materials you would want to use for different surfaces, you can basically pull in there and start building up networks and then mix them and blend them together. So you can mix together different types of surfaces, and it'll basically multi-layer them together into this really super cool material that you end up at the end. So apart from the diffuse material, which is just the gray that we see here, we also have a displacement. So just to run through the displacement in here, we've got the UV coordinates, which is the Pixar manifold, plugging into our texture here. And the texture is just this sort of like snakeskin scales, which is on here. And then we're using a Pixar to float, which basically just changes our RGB into a float value, which we're able to plug into our displace scaler here. And then once we've gone into there, we've got our Pixar displacement node in here, which we're plugging into our output. And we've also got this Pixar transform here. And this is where we're able to set our displacement height and displacement depth. So when you get an asset from ZBrush or one of the high-res sculpting packages, if you output a displacement map, what you can actually do is have this, for example, if this is set super high, like to 1 and 1 by default, you have your crazy massive displacement coming off the object. And then what you're able to do is basically go in and dial in the displacement based off the measurements that you use for the scene and get the optimum displacement for the object that you're using. So that's really useful to be able to set up the displacement and get the specific look that you're after, matching the original sculpting that you did. And there'll be information on how you can actually set that up. The other thing that's really helpful is it's got this remapping mode on here where you can set the displacement instead of going outwards from the object to be centered. And you can basically tune where the center is so that it can go both inwards and outwards on your object. So instead of starting at the surface of the object and going in one direction, it can basically sort of go in multiple directions, both in and out of your object. So once you've set up the material that you want on your object, we just jump out of the material library in here. I've added on and assigned a material in here where you can basically add all the different objects that you have in your scene, and you can put down the path of the object and the path of the material. So in this particular scene, I've got my box here, which we can see in the USD graph. And then all you have to do to drag it into the object is basically pull it in like this by dragging it into the object here, and it will pull the primitive into the material binding in here. And then for the material path, the thing I like to do is type materials, and it'll come up with the object in here. And then to get to the particular material that you're using, it's a good idea to look at the spelling of it, but it'll sort of half create itself in here and bring it up. So that's how you can basically pull in the materials and assign them to your objects. So now if we follow this down, the next thing we do is you merge the object into the rest of your USD scene. So by default, it'll just be all separate and live by itself, but in its own sort of like stage area. And then when you're able to merge it together, what you end up with is your full USD scene down the bottom. So if we go down here to the RenderMan settings here, just delete this edit. What you'll be able to see here is inside our hierarchy for our scene, we've basically got the RenderMan Studio here, which is our scene with a lot of different objects. And then we've got our box test object at the top here that we created. So one of the great things is you can just add these objects into your stage area, and it will integrate with the rest of the scene without having to go back to the original DCC app you were creating these assets in and then re-export the whole USD scene again. You can just add different components into the USD scene directly in Solaris, which is super, super helpful. Well, that concludes our lesson for class 2. I'll catch you again in class 3, where we're going to be covering how to set up material networks.